Ano si Philadelphia?
Narinig ba to? Hello?
No, I don't care about the people that they were doing. They'll feel thankful.
For sure. Yeah, no rush naman.
Pero minsan ayos sa tingin ko. Hindi ko there's
completely parallel to one of the constraints. So those are the only two cases, which means that either way, all corner points are optimal. The additional implication here is that the additional implication here is that uh, if you have an if you have an entering variable, so let's say you're performing simplex and your point is here. If you move to another point and the z value doesn't change, it likely means that you have alternate optima. And well, slight spoiler na to, but this can only happen when you have a non-basic variable that is zero in the tableau. Yeah. So that's the second thing. The third thing is that every every n-dimensional corner point, so every is bound by n constraints. So so what this means is that let's say I have a 2D LP because that's the easiest to visualize. It only takes two constraints to create a corner point. Uh, Even for this one, for example, this is an intersection between the constraint, this dotted constraint and the constraint x sub 1 is greater than 0. So it's still an intersection between two constraints. The exception to this is if you have more than n constraints. So let's say you have a constraint that looks like this. Uh, this is what you call degenerate LP. So spoiler lang ulit, what this means is that you have um you have a basic variable that is zero in the optimal tableau. Okay, so uh that's it for graphical method. So essentially, kasi, from what I recall in 41, there are also lots of uh somewhat semi-conceptual questions that will come out. Kasi they're testing if you really understand um what the implication of like an iteration in the tableau or what interpretation like in the graph really is, as opposed to just memorizing like how to do simplex, which I mean you should still do. I think that's probably the most important thing. Further, also gonna try to get these conceptual, so just be wary of that. So next up naman is uh simplex and yeah, yeah, just simplex. So step zero is essentially to make sure that is to make sure that you are in standard form. Oh, okay. So what are the characteristics of standard form? Una, that this is a max function. So what do we do if it isn't a max function? So let's obviously the only other case is the min function. What you would usually do is you turn it negative, and then it's a max function. So why does this work? So for example, let's like the most simple case. Let's say the thing we're minimizing is min w or min z x sub 1. So obviously, the smaller the value of x sub 1, uh, the more this objective function is being met, right? So obviously you have your non-negativity constraint. So kunyari you have a constraint here, and then x sub 1 is greater than or equal to 0. So obviously like uh as the value of x1 gets smaller, so like from 5 to 4 to 3, etc., you're getting closer to the optimal value of this LP, right? So kung inenegate mo siya, max W negative x sub 1, mapapansin mo na it behaves in the same way. So if it starts, for example, at negative 5, negative 4 is bigger than negative 5, right? Negative 3 is bigger than negative 4, etc. So you're also trending towards 0, but since it's negative, um, the smaller like uh, absolute value is actually larger. Like I don't know if that's confusing or what, but hopefully that makes sense. So yeah, that's the first, convert into max function. The second is to make everything an equality constraint. So oh my God, wait, oh my God. Uh, so to make everything an equality constraint. So there are obviously two cases that we have to deal with on hindi equality constraint, greater than and less than. So kung greater than, uh, obviously you'd have to convert it into equals. Pero how do we convert it to equals? So if you think about it, uh, the greater than or equal to means na, so kunyari, if something is greater than or equal to, let's say 5, right? Sure. Um, so obviously the numbers that fall within that are 5 itself, 6, 8, etc. So what that means is for you to get to 5, kasi kunyari ginawa mo itong equal to 5, but you still want 7, 8, and 6 to be satisfied by the constraint, you obviously have to subtract. So meaning, to convert, fuck, to convert greater than, you'd have to add a surplus variable, which means like the negative s s plus ka, which indicates an excess value. So equals, so the constraint, so just copy the constraint minus s plus equals the right hand side. So then the opposite is just true for less than, because if you think about it, kunyari 5, what would satisfy less than or equal to 5? So 5 itself, 4, 3, 2, etc. So what that means is convert it to equals 5. For the cases of 4, 3, 2, etc., you have to add naman to make sure it reaches 5. So that means that you have to add a slack variable. And this indicates like uh, kulang, like it indicates na it makes up for yung kulang so that cases less than or equal to would still uh, be satisfied by the constraint. So that's the second. Convert all constraints to be equality constraints. The third is make the right hand side in the tableau non-negative. So why is this important? Kasi recall na the right hand side is essentially the right hand side is essentially what the values of um the tableau are. So for example, if I have a tableau here, sorry, wait, there. So diba, this is the z value. Kunyari, this is, sige, let's just, okay. This is what you'd expect it to look like, right? Alright, sorry, nakalimutan ko yung top row. Um, okay, so in this case, since this is zero, these are your basic variables, right? And then these tell you, these are just reminders also as to which ones are the basic variables. So dapat magtugma na there's a one here, zero here. So this should help you track which one are the basic variables. And then these are obviously going to be its values, right? So it's important na yung starting values mo, if you go back to the constraint, it's important that your starting values are positive because by definition, laging may non-negativity constraints, meaning any at any point your your tableau in theory, your LP in theory, your decision variables should not have negative values. So kunyari kunyari if you have like let's say x1 plus 2x2 is greater than or equal to -5, you essentially have to convert that into um so naging less than siya kasi when you multiply everything by -1, you're also flipping uh the inequality symbol. So yeah, magiging ganun siya. Okay. So that's the third thing to consider. Um the fourth and last thing is that you should have non-negative decision variables. So actually medyo na-cover na natin siya. But yeah, essentially you cannot have non-negative decision variables. Okay. So that's basically the step zero of simplex. Not sure if we'll have time to cover like doing iterations for of simplex. I don't even know if I like can. Pero yeah, that's in terms of setting it up. So then step one, uh, let's just look at the general procedure of simplex. So after you've been able to convert the standard form, which is the first step, the second step is to um is to perform simplex. So essentially you can think about it in the following steps. The first is to select an entering variable. The second is to select a leaving variable. Uh, and then the third is to perform row operations and then check if you need to repeat. Okay, check if need repeat. Okay, so how do we do each step? So una, selecting an entering variable, uh, we choose the most negative in the tableau. So for example, bringing back our hypothetical LP. Oh my God. Sorry, wait. Uh, bro, I need to get a new pen. ko na lang. This tableau was a bit more different. So x1, x2, s1, s2. Okay, hopefully it's still legible. Kahit paano. So let's say this is still 0, 0. Let's say this -5, -3. Okay. Okay. So um okay. So the selection for the entering variable is basically just uh checking the most negative. So in this case, that's just -5. So I think baka itatanong sa exam why this is the case. You choose the most negative because it has the highest anong tawag? It has the highest uh it has the highest shadow price. So shadow price, what shadow price is essentially it is a way for you to somewhat estimate the potential increase that an EV will bring. That so parang in simple terms, if you had to pick one variable to enter the basis, and what that means is magiging non-zero yung value niya, you want to pick the you want to pick the variable na parang pinakasulit in a sense, right? Because they will bring the most they will likely bring the most increase for the lowest like for the lowest for the lowest quote unquote price as in change in the constraint. So yeah, basically that's the reason why you choose the most negative. In this case, that's that. And then after selecting an EV, you select a leaving variable. You select the LV, the leaving variable, and we do that by taking the ratio of this of the value here, right, on the Z column, time divided by this, right? So essentially, you're taking the ratio between this and this. So in this case, the ratio would be 4/6 and 2/6. This leads to 2/3, 1/3. So we choose the lowest of the two. So this is our LV, right? So same question, like same question. Why is this the case? Because the minimum ratio essentially tells you by how much will um what is the permissible increase of the entering variable. So the min ratio tells you by how much can the EV increase. Right, sorry. So actually, it kind of also it also gives you an idea na of what the likely value of the entering variable is, like in the next tableau. So after doing that, you do row operations. So I guess I think kaya nyo na yan. Like it's I know that's like medyo cop out, pero um essentially for this case, you create the necessary row operations such that the intersection of the column of the entering variable and the row of the leaving variable, so in this case 6, create the necessary row operations where this becomes 1. So magiging 1 dapat to, and makes this 0. So essentially magiging, so one other useful pattern, kasi I remember sa LE1 there, bibigyan kayo ng tableau na partially complete, and then from there you have to derive the full tableau, or you have to derive the optimal solution. So one of the most useful clues is na yung itsura ng basic variable will always be na may 1 siya in one of the rows. So for example, ito si x1 is a basic variable. One of the rows will have a 1, and then the rest will be 0. That is the telltale sign of a basic variable. And for sure, well, I think very confident ako na that will show up again in the LE. So yeah, essentially that's what they're doing to S1. Kunyari in this case, S1 is the entering variable because we want it to be part of the basic solution. The base. We want it to be part of the basis. So the set of variables that form the solution. We essentially want it to look like this also. We want it to look like this, right? And then x2 will change kasi yun yung leaving variable. So magbabago yung itsura niya. So yeah. A few important, so this is the, basically those are the important interpretations. To summarize lang, one, shadow price is the potential increase that the EV will bring to the not to the LP pala, not to the LP, to the Z value, while the minimum ratio is, it tells you by how much that EV can increase. So parang it tells you the limit. This is a bit hard to visualize, pero if you play around with the LP manually, you'll also be able to see na kung let's say 1/3 yung minimum ratio, the value of x2, or the value of S1 can only increase up to 1/3, and then like it'll break one of the constraints na. So that's what it essentially means for the minimum ratio. The third is that all BVs exhibit 0 in the 0 0 in the row, the row of the objective row, and then have zeros in the constraint rows, except for one cell which has 1, right? So yeah, the last thing I guess can be useful also when you're solving is na the increase in Z is always, so this is a property I think na, I'm not sure if this is actually like taught in class, but it's a very useful way to double check if you're heading in the right direction. The increase in Z is always the negative of the shadow price, right? Kasi yung entering variable is negative. So inanegate mo siya multiplied by the minimum ratio. You can test this out yourself. Pero the reason why this is important is it also just helps you during problem solving. So in this case, for example, without solving for the tableau, we know that the increase in the Z value will be -5 times negative of -5 times 1/3. So from that pa lang, you can pretty much tell what the increase in Z is. So that's obviously pretty useful kasi ayun nga, in some cases they will give you partial tableau, and then they will ask for like as much information as possible. So you need to understand how to interpret the tableau, not just like how to solve it. I'm pretty sure you guys know how to solve it already. So this is why we're focusing on that part, this part. So, ayan. See, that's it for simplex, for general simplex. Now, the next question, okay, actually, this is like half the coverage already. So we're on decent pace naman. So I guess since a lot of it is conceptual, does anyone have any questions? I'll just check chat. I'm assuming wala naman. Okay. Uh, sige. So this is how like in the best case you would do simplex. If the LP behaves in the way we expect. Unfortunately, there are times where it doesn't behave in the way we expect. So this is, I guess, step 1.5. Uh, Irregular LPs or uh, yeah, irregular LPs. So how do we deal with these? So generally, so why do irregular LPs happen? Usually, there are two reasons as to why you would have LPs that are irregular. The first is that they might be min problems, or not all min problems are like that. And two, typically it happens when the origin is not a BFS. Sige, we'll also explain like why this is the case conceptually. So why is it the case now if the origin is not a BFS, we'll have to do something like two-phase or big M. So the reason why that's the case is, kunyari, this is the, yeah, wait, sorry, to clarify pala. So this is the, sorry, this is the pinaka characteristic. If the origin is not a BFS, then automatically you'll have to do two-phase or big M, right? So the typical characteristics of that is you have min problems or if you have greater than or equal to constraints. So just to show this, kunyari I have an LP that looks like this. This is the feasible region. Just like this, then it's like this. So um so basically if you choose the origin, diba, it's not in the feasible region. So you can't proceed with simplex because it's not there. Question: why is it the case that we always start at the origin, right? Um, the reason why is if you look at the typical tableau, diba? So kunyari, I have, say, let's build a 3 by 3. So let's suppose max z equals 8x1 plus 4x2 plus 7x3 subject to uh, 2x1 plus okay, 2x1 plus 10x2 plus 6x3 greater than or equal to, I don't know, 5. And then just think of a bunch of random numbers. Plus 9x2 plus 8x3 greater than or equal to, I don't know, 3. 4x1 plus 7x2 plus 12x3 greater than or equal to 7. Okay, so, right, um, diba, kung, if it's greater than or equal to, right, okay, sige, wait. Let's do less than, just because it's a bit easier to explain this point. If it's less than, what we do to convert it into standard form is to add slack, diba? I add slack and surplus variables. So what that looks like is having plus S1 plus S2 plus S3. So magiging ganito siya. Now, the way you build that in the Tableau, diba, is, so I won't reconstruct the full Tableau na. Pero in the Tableau, diba, so your right-hand side is 5, 3, 7, S1, S2, S3. So obviously, magiging ganito siya. So remember what we said about what basic variables look like? Kasi diba, 0 yung value niya sa objective row, right? Because obviously, they don't exist. Wala, kunyari, I guess you could say kasi 0 S1 plus 0 S2, etc., etc. So remember what we said about what basic variables look like. 0 in the objective function row, and then zeros in the constraint rows, except for 1. So what this means is na, I don't think it was, well, when last year, I don't think it was explicitly said, or I wasn't listening lang. Pero from there, you can kind of tell na, this implies that regardless of whether or not we intentionally do it, the starting objective, the starting BFS is always assumed to be the origin, right? That's always the default starting BFS. So in cases like this, we have to find another way to get, like, to find some way to get inside the LP, inside the feasible region of the LP, so that you can eventually do simplex the normal way. So that's essentially the rationale behind two-phase and big M. So let's just go through each. So two-phase, essentially, given that you have a max function, you first omit that and you convert it into max something. So max Z, magiging max W. This is just convention, by the way. Doesn't super matter naman. Equals negative R1 plus R2 up until minus uh, Rn, where n is the number of constraints. Okay, so yeah. So then in the constraints naman, you basically have you write the constraint as is. So the original constraint plus plus R1 is equal to the right hand plus R2, etc. Note na you'll still have you'll still have slack and surplus variables. So yeah, just make sure na you don't forget that. You still have slack and surplus variables. Pero on top of that, you also have R. Now, what is the point of having R? The point is na somehow we can so what R1 and R2 does, you basically have artificial variables make the constraint. For example, kunyari you have a constraint x1 plus x2 I don't know, equals or greater than or equal to 5, right? Since greater than siya, diba? Minus S. So since the BFS 0, 0, right? Or the assumed BFS origin. So magkakaroon ka ng case where it's 0 plus 0 is greater than or equal to. So this is just impossible. There's no way to solve this. Pero what an artificial variable now. 0, so you have 0 plus 0. Let me just. So you have x1 plus you have x1 plus x2 plus x2 minus s1 plus r1 is greater than or equal to 4. So now, even when you start at 0, 0, you can still have a case where you have negative s1, so making 0 to s1 plus r1 greater than or equal. Kunyari, this is also 0. So now, this is still feasible. This is still feasible. Like, it's not automatically going to be impossible. Because now just r1. So that's what the artificial variable allows you to still be able to solve the problem, even if you're starting from 0, 0. But since the goal nga is to minimize r1, right? Because obviously to maximize w, these are all negative values. You want all the r values to be. So you're starting here where r1 is equal, but eventually you want to get to a point they all become 0. Because when they all become 0, that's when you can essentially substitute back yung ano. You can substitute f of x back. You can the original function back. Okay. So that's essentially what two-phase method does. So you start at phase 1, where you introduce artificial variables r to ensure that like the constraints can still be true even if you need artificial variables to make the constraints true, like the one we demonstrated. And then your goal now is to make sure that the value of r becomes 0. So what that looks like graphically is may iba kang feasible region kasi you have artificial variables. So it can look like anything. Whereas it essentially makes this entire segment like it's like parang fake feasible. Pero you're only gonna use that temporarily so that you can move, for example, to here, right? So when you move to this point, now that's part of the feasible region. So then you can drop the artificial variables later down the line because you're already part of the um, original feasible region, which is this. So that's essentially what two-phase does. So kulang pala yung space, no? Sige lang. For big M, naman, which is the other method, it also uses artificial variables, but the way it handles it is it doesn't require you to drop one of the like drop the original function anymore. So what it does is kunyari you have max z equals f of x. You just add negative m r1, negative m r2. If this is a min problem, you add plus, basta in the opposite direction. But yeah, for standard form, max, you convert it to max and then magdadagdag ka ng negative mr1 minus m. Again, rn, depending on the number of constraints. So it's always gonna be dependent. Oh my god. It's always gonna be dependent on the number of constraints. Okay. So essentially, this one naman, the advantage of Big M is that we're essentially solving like it's regular simplex lang. The only difference, obviously, again, is R, all the values of R will initially have values for the same reason as yung in-explain natin dito. But eventually, the R columns will become 0. So, sige, let's reconstruct a tableau. Kunyari, x1, x2, s1, s2, r1, or 2. So the goal eventually is na magiging 0 ito na value, right? So again, recall, um, kung 0 yung value ng isang decision variable. So like if it's a non-basic variable, then it has a value greater than or equal to 0 in the z row, the objective function row. So the goal is eventually hindi siya magiging part ng basic feasible solution. And then once it's done, once you successfully do that, you can just cover this row and then proceed like normal until you get to a feasible solution, until you get to the optimal solution. So again, the point that I want to make here lang is essentially these are methods to kasi point of simplex, the main assumption of simplex is na the origin is part of the feasible region. Kasi that's where it's the easiest place to start. You generally know na it's always a part of the feasible region. But for LPs where this isn't the case, so for example, like the one we made here, what the fuck? Okay. The one we made here, um, there is a way to still get there is a way to still get like an answer or an initial starting BFS by yeah, for introducing artificial variables. So that's essentially big M and two phase. So I guess the second to the last thing is so step 1.5.5 is or this is separate now. This is now special cases. So remember remember all the assumptions we made. So for example, the right hand side always has to be greater or than or equal to 0, or sorry, right hand side always has to be greater than 0, or um all the kapag 0 kapag 0 automatically basic solution to ganito, or yeah, greater than 0, all that. So there are special cases where that's not always true. Um, this isn't to say now what we previously said is just not a valid rule. These are still rules that apply to the vast majority of tableaus, and it's easy to spot naman. So let's just go over them para we can yeah, we can like cover all of them. So the first one is the infeasible. So I think yeah, infeasible. This is when you have no starting BFS. So wait, I'll just summarize it. Type, characteristic, uh, effect, effect or solution. So obviously, we just went over how to deal with this. The way to deal with an infeasible LP is to try to see if kaya siya via big M or two-phase. Second, if the second type is the also again this happens. Why does this happen? Um, this happens because sometimes origin, which is the default starting BFS, is not in feasible region. Shit. Yeah. Okay. So again, the way to deal with that is just to do big M or two-phase para you do end up with a starting basic feasible solution, and then you can proceed from there. The second type is the unbounded. That's when you have an EV but no LV. So the effect or the way to so there's technically no way to deal with that. It just means na z can increase forever. So I mean in the real world what that means is you probably have to recheck how you do the constraints. Pero for the purposes of like solving an IA41, what this just means is na the z can increase forever. Why does this happen? So there are a few things. Una, graphically. So what this looks like is, kunyari, I have a constraint that looks like this. So these are my constraints. So my feasible region, if these are my constraints, my feasible region is just this, indefinitely. And um, if my constraint was, if my objective function was this, then actually, I can still find the feasible solution, right? Pero if it's, so if pa ganun siya, but if it's in the other direction, then my z value can just increase without bound. That's the first property na I wanted to point out. Um, unbounded LPs are not the same as unbounded feasible region. So, diba, from this demonstration, if my objective function value is pababa or this direction, if it's a min function, it's still possible for me to find a corner point that can yield an optimal solution, right? Pero if I am a max function, pataas lang siya ng pataas without bound. So the true relationship here is na unbounded LPs are essentially a subset of unbounded feasible regions. So all unbounded LPs have unbounded feasible regions, but not all unbounded feasible regions result in unbounded LPs. So that's the first in terms of graphical. In terms of Tableau, this can mean two conditions. The first is na, diba, there's an entering variable, but there's no leaving variable. That's the definition of unbounded. So that means that you have a value in objective function, in the row, objective function row, that is less than zero, so negative. But uh, for LV, there is no value, no cell that passes the minimum ratio test. So why can there be a case that there is no cell that passes the minimum ratio test? So, okay, I'll build an example real quick. Kunyari, say, x1. Okay, so again, x1 is a basic variable. So, 0 siya dyan. Kunyari, this negative 5. S1 is basic variable. So, I hope you guys are picking up on the patterns also by me doing like random numbers and stuff. Kunyari, this is sige. Uh, it's negative 2, 0. Okay, so why can there be no value that passes the minimum ratio test? One way or one instance is, so remember the minimum ratio test has two conditions. The first is that it has to be positive. Also, sorry, it only has one condition, which is that this is the minimum positive ratio, right? So meaning, kunyari, here, in this tableau, obviously x2 is the entering variable, right? Excuse me. X2 is the entering variable. So What this means is that we're gonna be looking at this row, this column. Pero when we perform the minimum ratio test, so performing MRT, performing the minimum ratio test, this is 3 over -2, so it's automatically invalid. This is 1 over 0, which is undefined, so it's invalid. What this means is na we cannot pick a leaving variable because every single possible option yields either negative or undefined. So, meaning, definitionally, we have an entering variable but no leaving variable. So that's another example of, or that's another way to visualize what unboundedness is. Okay, so okay. The third case is alternate optimal. So as I said at the start kanina, graphically what this looks like. Also, okay, let's just go. Characteristic nito is na you have so you have you have an EV, you have an LV, but you have no change in Z. What does this mean? This means na successfully nakahanap ka ng value, nakahanap ka ng entering variable, nakahanap ka ng leaving variable, but it did not improve the Z function, right? So, what is the effect of this? This just means na you essentially move to a different corner point. Oh my God. Right. So graphically, what does this look like? Kunyari, this is my LP. This is the constraint. And then this is the constraint. And kunyari, this is my objective function. So meaning, I can start here. Kunyari, I'm here. This is already optimal, right? Kasi this is the objective function. This is already optimal. Pero there's a chance na the simplex will say it's not yet done. And I will move here. So magmo-move ako to the here. So magkakaroon ako ng may entering variable ako, may leaving variable ako. Pero walang nagbago sa z value because they're both equally optimal, right? By definition, if you have alternate optima, multiple sorry, mali pala, dito pala. Yeah. By definition, I have multiple I have 2 points or an infinite number of points that yield the same optimal z value. So yun yung mangyayari. What does this look like in the tableau? This looks like if a non-basic variable uh, has a non-basic variable has 0 in the LP. So kunyari, okay, so x1, di ba? Standard lang. 1 dito because that's the pivot. And then 0 siya sa objective function row. Same thing here. Pero kunyari, this happens. So, okay, right. So this is technically optimal. Pero 0 rin to. Even though S1 is not a basic variable, 0 siya. How do we know? How do we mathematically show that this proves that the z value will not increase? So recall, yung binigay ko na somewhat shortcut, the increase in z is equal to the shadow price times the right hand side over the column, or in other words, the minimum ratio, right? So, sige, kunyari, we force x1 to enter the basis. So we force another iteration na si s1 magiging basic variable. So we look at this, right? Look at this. So we look at this. So 5/6, 2/2. This is the minimum ratio. Okay. And then you can perform the simplex yourself. Pero, again, from our shortcut, shadow price is 0, right? Shadow price is 0. Minimum ratio is 5/6. So yung z value, magi-increase siya by 0 times 5/6 equal to 0, meaning no change, right? So that's another way to be able to check very quickly um, alternate optima. And this also shows why yung sinasabi ko na shadow price times minimum ratio works, just to show by how much z will increase. Okay, that's the third type. The last type is degeneracy. Um, what this looks like is you're cycling at the same point because you have a basic variable with value 0 in the right hand side. So ito naman, so this is the, kasi both alternate optima and degeneracy have zeros. So I admit, nakakalito siya. So how do you tell the difference? So in degeneracy, you have a basic variable with 0 in the right hand side versus the alternate optima where you have a 0 in the objective function column. So that's the difference, right? Pero another way to see it graphically is kung yung alternate optima, lumilipat ka sa from one corner point to another, and then parang hypothetically back and forth, di magbabago yung z value. Yung cycling tuloy. Yung degeneracy naman, you stay in the same point. You stay in the same point, and you don't move at all. So yun yung difference. Same na hindi nag-change yung z value mo. Sa alternate optima, the z value doesn't change even if you're moving. Yung degeneracy is you're just not moving, like graphically. So example of that is kunyari ito. Okay, wait, I'll think of a better example. Okay, fine. Yan. So here, this point is an intersection of three constraints in 2D. So recall, corner point, a normal corner point, in n dimensions is only requires n constraints. So in a 2-dimension LP, a corner point should only be covered by 2 constraints. This one is covered by 3. What is the implication of this? Another property that you guys need to be aware of is so this is where I bring in the concept of binding constraints. So a binding constraint is when you can treat it like an equality. So it's essentially an equality. So kunyari, sige, wait, I'll show the full thought muna. So a binding constraint basically is kung equal siya. The implication of that is your slack or surplus is equal to 0, right? And when your slack or surplus is equal to 0, this means na this constraint is important in defining the intersection of the current iteration. So I get that that's a lot of words. So I'll try to show it visually. Kunyari ito, simple lang na LP, na feasible region. Here, the binding constraint is just the non-negativity constraints, right? So at point 0, 0, binding yung x1 greater than or equal to 0, x2 greater than or equal to 0, right? And recall, like the way I try to look at binding constraints is, pwede mo siyang gawing equal and they would still hold, which makes sense, right? At point 0, 0, nag-hold pa rin siya even if it's equal, right? So, yan. Um, yeah. So that's what a binding constraint is. So so why is this important in understanding degeneracy? It's important in understanding degeneracy because uh, regardless of how many points intersect, the you will only need n constraints nga to define it. So meaning you have n binding constraints. So in something like this, kunyari this is x1 greater than or equal to 0. Kunyari, this is constraint 1, this is constraint 2, right? So kunyari in iteration, so this is iteration 1, right? This is iteration 1. The binding constraints is x1 greater than to 0 and constraint 1. Pero kunyari, magbago yung binding constraints. Magiging 1 and 2, right? So this is now the binding constraint. The problem is, if you look at it, the point that refers to the intersection of point 1 and point 2 is still the same point. So hindi ka gumalaw, right? Even though you changed your binding constraints. So what this means is that even if nagbago yung binding constraints mo, you still did not move. And the point of simplex device, you move across the feasible region until you get to the optimal solution. So meaning you're stuck. In some cases, you're stuck forever, and that's what's called cycling. Pero not always naman. Maybe you'll just encounter the same set. So maybe uh, iteration 3, babalik ka sa X, ganito. But then eventually you'll be able to get out of it, something like that. Yeah. So that's degeneracy. So okay, 9:21. It's been over an hour now by a bit. So I guess that's a lot of info. Um, okay. So I think okay, the way we'll go about this is I'll check for word problems that make sense to do. So kalkalin ko lang yung inbox saglit. Pero while waiting, do you guys have any questions? Since like we're quite di naman early, pero we have a bit more time. No questions. AJ, in case may questions sa screen, could you also check? Like sa YouTube live. Couldn't hear you if you were talking. Pero sige. Okay, thanks. Sige. So I think the last topic na is very hard to summarize is word problems. So I guess para we cover everything and or we're efficient, the last segment we can just do our yung LP formulation na word problem. And then so I guess we're still solving something, pero yeah, we're also covering the topic na can't really be summarized. Sige. So I will send a word problem that we're gonna do together. Um, is there a way for you to flash it, AJ? Kasi I think people had a hard time using, like yung last year's video, people were watching it. Hindi daw malinaw from my iPad when I flash it side by side. So I think we might need to like flash it separately. Like, is there a way for you to, if I send you the problem, mapa-project mo ba siya? Okay, thank you so much. I'll send it to you first. And then I'll send it on Discord. nakamiss din tong kinda. Not really, but forgot a lot na. Wait lang. I'll upload this to ano, study room for chat. So like the chat attached to the video call itself. Study room. Okay. Uh, okay. I sent it na. Study room for chat. So, sumabay na lang kayo from there. Kasi, ayun, projecting it apparently doesn't work. Medyo malabo daw yung stream from feedback. Okay. So, let's adjust to that. Okay. So, I'll just read it as well in case di nyo makita. So, a 10-hectare lot previously inhabited by informal settlers is to be cleared for an urban renewal development project in the city of Manila. So, not very politically correct example. But okay. Two housing plans are to be considered: low income and middle income housing. The types of housing can be developed at 20 and 50 units per hectare, respectively. The unit costs for the low and middle income housing are 350,000 and 650,000, respectively. The lower and upper limits set by the officials on the number of low-income housing units are 60 and 100. Similarly, the number of middle-income housing units must lie between 30 and 70. The combined maximum housing market potential is estimated to be 150, which is less than the sum of the individual market limits due to the overlap between the two markets. The total mortgage committed to the renewal plan is not to exceed 65 million pesos. Finally, it was suggested by the urban planner that the number of low-income housing units must be 50 units greater than one half the number of middle-income housing units. Okay. So the first sub-question asks us to formulate the minimum cost renewal planning problem as an LP. So um um, okay. So the way I would suggest approaching word problems in general, so just making it generalist a little, is first just take all the facts. So let's start. Two housing plans are to be considered. This implies we have two variables: low income and middle income housing. So along the way, I'll just write the important parts. Let X1 be low income housing. Let X2 be middle income housing. Declaring variables important here kasi they really gets naman like medyo di naman pedantic, but they really like punish you for small things because it is LP formulation after all. Like the LP has to be perfectly formulated. So yeah, along the way, try to write down everything you can. The types of housing can be developed at 20 and 50 units per hectare. May sinabi na ba? 10-hectare lot. So the way I would go about this is, so ito, my 10-hectare lot. This implies capacity. So from the start pa lang, I would put less than 10. Oh, wait, lipat ko nga siya. So 10-hectare lot. From the start pa lang, I don't know what it's gonna equate to yet, but I know it has to be less than or equal to 10. And then I have two decision variables because I have two housing plans. So matic, I have X1 low income housing, X2 middle income housing. The types of housing can be developed at 20 and 15 units per hectare. So this one gets a bit difficult. So let's break it down a bit slower. So 20 units So this is units. This is in units, right? So you might be tempted to just be like, this is just x 20x1 plus 15x2 less than or equal to 10. But no, because we get 20 units per hectare and 15 units per hectare respectively. So given that our variable is in terms of the number of units, we have to think about like how do we convert that into units? Because we have 20 units per hectare. So this is where I guess dimensional analysis comes in. So if you, I think Physics 71, the I think Chem2 also has dimensional analysis. So diba, the way you would write um something like this is like 20 units per hectare per 1 hectare, meaning uh on a per unit basis, you have 120 hectare. So 1 hectare over 20 units. Same lang yan, di ba? Pero now, essentially, you can rewrite this as 120 hectares per unit. Because that's what the denominator is, right? Per unit. So now, right, if we plug this back in, it makes more sense, right? 120 x1. Right? Kasi if x1 is equal to 20, kunyari, edi, this whole statement becomes 1. Naging 1 siya. 1 over 20 times 20, right? Which is what the constraint is saying, right? Because it's saying na for every 20 units that you build, uh, for every 20 units you build, you use up 1 hectare, right? This constraint refers to hectares, right? So it only makes sense na you need 20 units of x1 to reach 1 hectare, is what this is saying. So applying that same logic there. That's the first one. So that's the first constraint. I'll try to, how do I do this? Okay, sige. I'll leave the small notes sa baba. So this covers this one. Okay. The unit costs of the low and middle income housing are 350K and 650K respectively. So just to save on time, because I did remember LE1 being a bit gipit on time. Let's just put 350 x1 plus 650 x2 less than, we don't know yet. Di pa natin nakita sa problem. This is the cost in 1,000 pesos. So just be precise. Since inomit natin yung thousands, you also have to say it's the cost in 1,000 pesos. Okay. Oh, sorry. Fuck. Oh no, Venus. I'm really tempted to borrow it. Okay. The lower and upper limits set by the officials on the number of low-income housing units are 60 and 100. Similarly, okay, yun muna. So let's set this aside muna. Tells us that x1 essentially lies in the range of 60 and 100, meaning x1 has to be greater than or equal to 60, x1 has to be less than or equal to 100. Okay. I mean, pwede mo naman tong isabay, but it's like, the standard convention for LPs is that you isolate the right-hand side and you don't have like double. So just err on the side of caution. Right. Also, this is a slight tip for speed. When you're writing LPs, try to make the decision variables same across the column para hindi kayo maduling. So what I would do is I would write it all the way there, even if maraming space. It just helps, especially for LP formulation. Okay. Next, similarly, wait, highlight lang natin. Such para we know we've gone through that na. Similarly, the number of middle-income housing units must lie between 30 and 70. So same logic as well. 30 and 70. Okay. So straightforward naman yan. The combined maximum housing market potential is estimated to be 150, which is less than the sum of the individual market limits. 100. Wait. Let me just try to understand the grammar. So housing market potential is estimated to be 150, less than the sum of the individual market limits. What this just means is that so the total number of houses that can be on demand is 150. So what that means is that um, and it's less than the combined kasi the combined is 100 plus 70 due to overlapping demand daw. So this is x1 plus x2 less than or equal to 150. So we don't build more than 150 houses because the maximum potential daw is 150 houses. Highlight ulit. Excuse me. The total mortgage committed to the renewal plan is to not exceed 65 million. So where does that come in? That comes in to the cost in 1,000 pesos that we set. So 6.5 million. Sige, let's para no shame. Para hindi tayo maduling. Then we cut off 3 zeros. Okay. Yan. So labeling lang ulit. This is limits set. This is also limit set, like arbitrary siya. And then this is max market demand. Okay. Finally, it was suggested by the urban planner that the number of low-income housing units must be at least 50 units greater than one half of the middle-income housing units. So very like LM math-ish na yung stack, nakapatong yung statements. So let's pick it apart now. I'm not gonna highlight it now. I give up on this pen, sorry. So suggested the number of low-income houses must be at least 50 units greater than one half. So you have the middle-income housing units, one half of the middle-income housing unit. So that's one half of X2 must be at least 50 units greater. So plus 50, meaning the low-income housing units daw, which is X1, should be greater, at least 50 units greater than one half the number of the middle-income housing unit. So in literal terms, the low-income housing units must be at least 50 units greater than one half of the middle income housing units. Again, we have to standardize this in LP form. So okay. So this becomes x1 minus 1 half x2 greater than or equal to 50. What I did is just transpose this. So I moved this to the left-hand side. Okay, so nangyari dyan is x1 minus 1 half x2 is greater than or equal to 50. This is, sino nagsabi nito? Si Urban Planner. So I'll just put Urban Planner. But I'll be more precise in the LE in case. So Okay, these are the constraints. But what is the original objective? The original objective, uh, the original objective is to formulate the minimum cost renewal planning. So these are our constraints. Para madali, I'll just write 3A here. So the objective function is minimum z, uh, and then we check the cost 350 x1 plus 350 I plus 650 x2. Essentially, that is what we're minimizing. That is the cost, right? Subject to all these constraints. You will notice na potentially this constraint is unnecessary because as much as possible, you want to keep within the minimum naman. So there's a potential na this constraint will not come into play. But I think for the purposes of completeness, just include it because it's part naman. The renewal plan is not to exceed 65 million. So that's for 3A. For 3B, it asks us to modify the LP if the objective is to maximize the number of units being constructed. Uh, so again, if x1 and x2 represents the units constructed, then we just put it at max z x1 plus x2. Yeah, that's essentially it. Uh, just to double check, uh, I'll make sure na tama yung pinag-copyan ko. Uh, uh-huh. Okay. Okay. Check ko lang sa Podi ko. And mukhang tama naman yung ginawa natin. All right. So that's it. So that's an example. I guess sige, to generalize, what are the potential what are the general types of constraints that you will have? The first is you will have maximum capacity. This is in the form of resources. This is in the form of time. This is in the form of manpower, etc. So just to recall, just to make sure that you're assigned. So essentially, the format here is decision variable times the cost is less than or equal to the max cost. That's the typical format. The second one that you will typically experience is min benefit. Uh, so I think, for example, ito, at least 30 homes, right? Uh, yung itsura niyan is usually DV times benefit is greater than or equal to the min benefit. The three is relationship. So for example, yung constraint na this constraint, that's an example of relationship constraint. My tip here again is to first check it, to first write it in simple terms, which is what you see here. This is how you would interpret it literally in your brain. And then you move the variables to one side. Uh, it's really important to be careful here kasi yeah, it's one of the more challenging. So ayan. What else? Trying to remember. Tignan ko lang yung LE1 naman. Uh, but yeah, since I guess we're on track to finish early, I'm happy to take questions if you guys have any. I'll check out LE1. Although, kasi the reason why I didn't use the LE1 from last year is they didn't return the question. Uh,
Q, I have a question.
go.
Um, when you took the exam last
Yes.
year, was there the missing values in the tableau? And if so, what are your like tips on solving that?
Sure, okay. That's a good question. I'm trying to guess what the questions were based on my. Uh, okay. So problem one was ano, solving LP formulation. I skipped this. I went straight to problem 2. I did problem 1 last. Also, that's the other thing sa 41. Super underrated. Skip questions. It's okay. Like, they put the harder questions first sometimes. Uh, question 2 was big N. Ano, question 2 was space, 2 phase. Question 3, I think this is the one na, so this is big M, pero I think this is the one na may tinakpan. I joke. Yeah. And then problem 3 was graphing. Okay. So, I think, sige, let's answer yung question ni Raf directly. So, my first instinct would be to identify which the basic feasible solutions are, which variables form the BFS. Because what they will usually do is nakatago rin to. This row, nakatago rin yan. So the first thing that I would do is really just figure out which variables are the BFS. Again, the way you can tell is zero siya dito. But diba from our discussion, alternate optimal can also have zero in the objective function row. So the next thing that you check is eto, whether or not it's zero in every row except for one row na one yung value niya. That's how you can tell. All basic feasible solutions are like that. All variables that are part of the BFS are like that. Once you can solve for the BFS na, my next thing would be to try to get relationships from the other from the other from the information. So let's say kunyari, I think one way they would do it is like, for example, let's say they itago nila to na values. But what they will tell you is that let's pick a better one. Let's pick a better tableau. Okay, ito. Kunyari, itatago nila to. Pero what they will tell you is the minimum ratio of, sorry, take 3. Kunyari, ito. Itatago nila na the z values are 4 and 2. But they will say, if simplex is performed, the minimum ratio is 2/3. So, parang magbabacktrack ka. You're given na, alam mo na 6 to, alam mo na 2/3 yung minimum ratio. So, it's like, blank over 6 is equal to 2/3. And then malalaman mo na, from solving that, you will know that this is 4. So I guess that's one example. Another one would be yung sinabi ko nga na shadow price times minimum ratio is equal to the increase in Z. That's, well, hindi pa naman kayo matrix form. I think that's LE2. Pero that's also one of the shortcuts even from LE1 pa lang. The minimum ratio times the shadow price is just equal to the increase in Z. So that's another relationship you can use. I guess those are the two most important ones. So minimum ratio, kasi even if you're only given the minimum ratio and one of the numbers, you can tell the other number because this is a ratio, diba? So that's, yeah. To summarize lang, because it was a bit messy. Number 1, hanapin mo ASAP which variables are part of the basic feasible solution. So that will give you 2 or 3 pieces of information. And it will also tell you that everything else is not basic, not part of they're not basic variables. The second part is to use numerical relationships that you know, like the minimum ratio, like the shadow price relating to shadow price times minimum ratio being the increase in Z, yung mga ganun. So all of these will help you, parang mag-domino effect siya. Once you find information for one, you find more information, and then you can eventually fill out the tableau. So yeah, I hope that answers the question.
Yeah, thank you.
Yeah, no worries. Anyone else? Kasi if not, I'm also okay to just end it early. Magti-10 na rin. And yeah, I have something tomorrow. I kind of need to prepare for something also. So, ayun, I guess we can cut it off there. If you have questions, especially like for solving, because I know, I think some of you expected more solving, no? And I wasn't really able to deliver on that. So if you have questions, go lang. That's fine. Um, and yeah, that's it. Uh, thank you guys. Answer the feedback form, etc., etc. Good luck in the exam. For questions, you can reach out to me. And yeah, uh, yun lang.